thank you very much for joining us here on AU Manufacturing Conversations.
Thanks for having us.
I'd like to ask both of you the standard opening question, and that is, how did you get here and what do you make?
My name's Ian Fordyce, here with Conflux Technology, and basically we make 3D printed heat exchangers for a whole range of different applications. I personally got here, I've got sort of a recent research background, did a PhD in additive manufacturing at RMIT, previous to that mechanical engineering, previous to that a automotive mechanic for 9 years. So a bit of a trade and research background, and basically I was taken on at Conflux to be part of research and development within the company and to help with collaborations with universities such as the project that brings us here today, which was a alloy design project with Deakin, which leads us on to Balaji.
Can I just ask if you did your PhD under Brent?
I did, yes.
Awesome.
Yes.
He's a very, very nice old dude.
Yeah, he's great, yeah. Very knowledgeable and very well connected in the AM and advanced manufacturing industry. Yeah.
Certainly.
I'm Balaji. I'm from Deakin University. I'm working as an Associate Research Fellow, where I've been involved with Conflux in the last 9 months in developing alloys for their heat exchangers. I come from a background with materials and metallurgy, where I started my PhD at Deakin University, where I was working on developing high-strength steels for mining equipment. After my PhD, I was working for University of Waikato as a lecturer with a materials background. So during this time, I have developed a lot of interest for additive manufacturing 3D printing metals. So that's where it brought me towards Conflux working on this industrial project.
Just for a bit of background for anyone who doesn't know Conflux too well, Ian, could you just tell the audience something about some recent work you've been up to and the kinds of things that you do?
Yeah, sure. Like I said earlier, we 3D print heat exchangers. So basically, heat exchangers, just think of the radiator in your car or, part of an air conditioning or heating unit, anything where we're transferring thermal energy from one fluid or gas into a different fluid or gas. So Conflux generally works in a process where our clients come to us with an empty workspace and they'll tell us that they've got this fluid or this gas coming into this workspace at a certain temperature or pressure, and they want it to come out at that temperature, pressure, flow, etc. And then they get us to go away and design a heat exchanger to fit that. So we go away, we do our calculations, we do design, we build a part, we calorimetrically test it, and we compare our experimental test data to our design data and also our customer requirement data. And then we can confirm whether or not we've fulfilled the design brief, and we give our heat exchanger across to our customer and they put it in their system and off they go. So yeah, as I mentioned, we use 3D printing technology, and the basic reason for that is that with 3D printing you have much better freedom for geometric design. So we can cram a lot more complex geometry inside a heat exchanger, which essentially gives us a lot more control over the amount of surface area inside, which is very important for heat exchange. And we can also customize the way that the fluids flow through the heat exchanger. Certain things like this you can't do with traditionally made heat exchangers.
So you're developing products at very small volumes in a very specialised way for demanding applications, basically.
Exactly, yes.
What would a typical batch be for a customer?
Depends. We've done small batches, which will be a single part, done others, up into the dozens of parts.
Tell us about this 9-month project that is on display on the floor out there.
The motivation behind this project is that with 3D printing in metals, it's still, in terms of the world of manufacturing, it is still a new technology. And we are kind of restricted in the materials that we can use. So we mostly use aluminium. We also use stainless steel and a few other interesting alloys. But basically, at the moment, we're at the mercy of what we can purchase to use as aluminium feedstock. These alloys aren't really ideally designed for heat exchange applications. So basically, we're motivated to say there must be better alloys that can be developed for our applications. And that's where we engage Deakin. We can take advantage of their metallurgy and alloy design process. And that's where we get a researcher like Balaji to come in and work with us to develop new aluminium alloys, with the end result being they would be turned into metal powder and turned into 3D printed heat exchangers.
You can buy metal powders off the shelf. Why are you not just doing that? And tell us how you're doing better than that, presumably, in your lab, Balaji.
In terms of metal powders, what you could do is you could buy the existing standard powders that are available. But what we have done in the 9-month period is something, we have put a lot of effort and research into existing alloys that are available on the market as well as in the scientific studies. And from there we have taken the best possible results, and we have developed new alloys based on Conflux requirements. Just for example, like they have Conflux, at the present they have a set of baseline alloys. So we have developed alloys that perform at least 10 to 15% better than what they have in terms of strength as well as like thermal properties or in terms of even corrosion resistance. So that was the whole idea about the alloy development. Conflux has a vision of developing alloys that match the highest possible standards of the existing alloys in the market. So with that idea in mind, we started to develop a series of alloys that could really go above and beyond in terms of their performance, not just in strength but also thermal and other aspects of it. So that's why it's very hard for us to pick something from the existing market. We want to go beyond that and develop alloys that is going to compete and match international standards.
Developed a series of alloys. Are they being used in Conflux projects or sold or both?
It's too soon. Basically, the project finished a month ago, and this was a massive amount of work that was crammed into a 9-month project. We're at the stage now where we need to sit down and sift through all the test data, and as Balaji mentioned, that's all measured against reference commercially available alloys, and then we'll compare it to other high-performance aluminium alloys as well, and make our choice about which novel alloys we decide to move forward with. So yeah, they're not at the stage yet when they're being turned into powder and turned into heat exchangers.
You're a private company working with a university, and you do that quite a bit, I imagine, given the technical nature of your work. How does it normally look? Is it something done through a CRC program like this, or is it something that goes on informally a lot, or do you get consultants from university to pitch in? What's the story?
Yeah, a bit of both, actually. So yeah, this project was obviously done through IMCRC, which has been awesome, having their support and their facilitation in sort of joining and guiding Conflux through the process. But we've also, one of the side effects of this is just building relationships with Deakin researchers and academics, and we're able to sort of get more sort of informal side projects going as well, whether that's literally bumping into someone in the hallway and having a chat, or engaging services for material testing for a slightly different internal R&D project, or just chatting about future possible partnerships and different possible projects. So there's a good mix of very formal structured projects and collaborations and informal as well.
And being located at Manufutures as you are, is that a big advantage for this project? Is Balaji just down the road?
Yeah, it helps knowing that your researchers and your people you're collaborating with are literally across the road. Yeah. We're
at the Innovative Manufacturing CRC event. We're talking about innovation. What's a personal definition, if you have one, for innovation?
It's a hard question. I think what comes to mind for me is collaboration and evolution. And by collaboration, I mean people working together, but also just collaborating with different technologies working together to create new technologies, which is obviously a very important thing with, alloy design. There's nothing new about the elements that we're putting in the alloys, but the actual end result is a new material. So, yeah, it's a rough, vague definition from me for innovation.
You're allowed those?
Yeah, cool.
Balaji?
In terms of innovation, for me, it's all about finding simple solutions for complex engineering problems that are more relevant. So innovation could be as simple as a simple design that is going to work effectively without much of a hassle or tweak and things like that. So that's what I feel is innovation. As Ian said, it's all about connecting, collaborating. If you're able to collaborate and connect with the right technology in the right place, I think that's personally an innovation for me. It doesn't have to be like rocket science. A simple design with a foolproof system is still an innovation. That's going to work for years and years and years.
So you're keen on elegant solutions, if they can be found?
Yeah, that's right, yeah.
And lastly, a recurring question on this series is, why does Australia need a strong manufacturing ecosystem? What would your answer be?
Could say a very boring answer because it's good for the economy, but also I think it's just, as we've seen the last few years with COVID and the difficulties that we had with local manufacturing. I think that really highlighted the fact that we need better systems in place in Australia. But also, manufacturing is technology, and this sort of goes hand in hand, like with having a more advanced society in general. You're not going to find a country with very advanced technology but very, very poor, health systems or education systems. Like it's something that's a product, but also an accelerator for all, the rest of society to improve itself.
Yep. Yeah, well, you're in a technology business, you should say so.
Yeah, not biased at all. So.
Indeed. And Balaji, your thoughts?
Yeah, I think I would touch upon with Ian's comments as well. Like, in terms of manufacturing drives the economy, that's undenying. But the other most important thing is, like, as Australia have always been known to be a sporting nation, that's what one of my supervisors used to say. But the last 20 years, we have been making strides to not change the perception, but grow in the area of manufacturing. That's going to help in terms of not just the economy, but in terms of the manufacturing sector itself, because we have all the expertise and as well as materials and resources. It's just a manufacturing we need a bigger push to start establishing that. So I feel like if we could get the manufacturing done here, we could create more jobs and also the platform for future technologies to emerge in Australia. So far what we have been doing is a lot of these technologies come from Europe or like North American countries or those like highly influential academic institutions in America. But we do have the base, but we don't have the push and the funds and things like this to have this push here. So I think that's why we need a strong manufacturing base here for these to go hand in hand.
Good answer. And lastly, is there anything you'd like to plug or a comment to make or something we should watch out for?
I'll just say check out the Conflux Technology website. We're always putting up new case studies and new information about new products and new projects that we're a part of. So yeah, if you're interested in advanced manufacturing, 3D printing, or if you're really keen on heat exchangers for some reason, then yeah, check out the website.
Yeah, I mean, in terms of here in Australia and manufacturing, like I think from now on, I think we have already started this, which is a very healthy sign. I think there'll be more industry research collaborations with universities, and this will take a different turn in future, not just being collaborations, but in terms of more like startups coming up within the university based, and this will just get better and better from here. So I think we have got a bright future ahead in terms of Australia and manufacturing industry universities.
Awesome. Well, that's a lovely note to end on, and it's been a fun conversation, but that is the end of it. Ian, Balaji, it was lovely to meet you both, and thanks for joining us here on AU Manufacturing Conversations.
Oh, thanks for having us. Appreciate the time.
Thank you.
Thank you.